Today we're going to start on a new topic about energy, right? We've finished the light energy. Now today we're going to do the heat energy, right? And one very important characteristics that accompany the heat energy is that the temperature, right? Cold and hot, how hot is it, how cold is it? So heat energy basically will actually determine how hot and how cold you feel, etc. What is heat? Heat is a form of energy, right? Until now, we are not talking about energy. The last time we talked about is the light energy. Today, we'll talk about the heat energy. How heat makes things cold and make things warm, right? We need heat to keep warm and to cook our food. We need fire and heat to cook our food, right?
Yes.
Okay.
Fire makes things warm.
Yes, not only that, fire helps us to keep the heat, not the fire. The heat comes from the fire. So
It also can make everything hot and burnt.
yes, correct.
If
Okay.
you put like sun leaf down there, then the fire put there, then the leaf
Yes.
will burn.
Yes. So heat energy is a very important and at the same time can be
If
dangerous
it's
as well.
cold outside, that means make everything cold.
Yes. So when there's a lack of heat energy, basically things will become
About
colder.
what's this?
Where do you find heat? Sources of heat. We call it sources of heat, right?
Like the sun.
Yes, the sun is our main source of heat, right? The sun basically gives Earth is the Earth's main source of heat. It gives living things on Earth warm, right? It keeps our living things on Earth warm. Can you name some everyday items that give out heat? What give out heat? The fire, right? From the stove give out heat. What else give out heat? Sometimes the light also give out heat, right? Correct or not?
And something that's hot.
Yes, definitely, right? Heat makes the thing
Like
hot.
sometimes you're hot.
We also give out heat, right? As living things, we give out heat as well. Remember, like, as when I start these particular lessons, we talk about heat energy, right? And then we have, I say that there's very highly related type of characteristics that associate with heat energy is temperature. So what is temperature? Right? Every day you go to school, right? The teachers actually took your temperature, right? Take your temperature, right? What does temperature do? Temperature is a measure of how hot something is, how hot or cold something is. So temperature is measured with a unit called degrees Celsius, right? Degrees Celsius. The higher the value of temperature, the hotter the temperature, right? What is your body temperature, may I know? 37.2 degrees Celsius, right? Anything higher than 37, like for example 38.1, 38.2,
Papa,
you're having a fever, okay? We are actually we are warm blooded, so our temperature is almost constant, independent of our environment. How do we measure temperature? Right, we use a thermometer to measure temperature, right? Okay, there's a lot of different types of thermometers. Later I'll show you a few types. There are different types of thermometers that can be used for different purpose. So to measure your body, right, we use a clinical thermometer. A clinical thermometer measures our body temperature. Then in the lab, when we want to measure the temperature of a body, like for example the water in a beaker, right, the water of a body, we use a laboratory type of thermometer. We call it a laboratory thermometer.
Papa. Very long.
So these are some of the different clinical thermometer. We used this before, right? The one that actually just
It's
contactless.
cool.
It's
It's
cool, right?
cool.
It's called the infrared clinical thermometer. These two over here,
These two the doctor use.
yeah, the doctor used to what? Put in your mouth, right? Or put in
Some
the,
put in the mouth, some put in the ear,
yeah, there's a ear
some
one.
put on the forehead.
No, usually they put in the mouth, right? They are.
But why did I put on the forehead?
No, usually they don't. This one is put on the forehead because it's contactless, infrared. The one that is using the bulb one, there's bulb that you put under the tongue in your mouth. They are sometimes called oral clinical thermometer.
When they put on the tongue and
Under
then
the tongue.
then what will it do to you?
Nothing. You just stick there, and then after 1 minute, you come out, and then you look at the temperature scale to look at your temperature. This is called the oral mercury type of clinical thermometer. The other one is a digital oral clinical
To
thermometer.
put where, Papa? In
Under
your
the
ear?
under the tongue. Both are under the tongue in your mouth.
How about this?
This one is you always use, right? This is called infrared contactless clinical thermometer. Is used to actually use infrared and therefore is contactless. These are These are bigger thermometers. It's used in a
Then what's
laboratory.
this for?
This is to measure the heat in the body. You can stick this into a muffin, you can stick this into a pot, etc., into a beaker, into a water, into anything to measure the temperature. This is not for not to measure body temperature. It's not to measure. Can
It's
I
just
have
to measure food.
Yes, measure
But
food.
what is this for?
This is to measure food, measure body. For example, you have a pot of water, you have a pot of soup, you want to measure how hot it is, you use this. This is called a laboratory thermometer.
Laboratory
Thermometer.
thermometer.
Yes. Good job. Yes, but how do you read the temperature of a thermometer? Okay, this one we'll show you. Okay, I will demonstrate to you. But first, I need to get a thermometer. So what you need to do is hold the thermometer outright. Okay, for example, this way. Look at the level of liquids in the thermometer. Step 3, position your eyes at the same level of liquid in the thermometer.
Papa, excuse me. There's a thermometer that can squeeze out water.
No, it's not. It's not a dropper. Right, it's a thermometer.
Oops.
Step 3, position your eyes on the same level as the liquid in the thermometer. And step 4, read the marking nearest to the levels of the liquid in the thermometer. We're going to get a thermometer. We're going to actually measure the temperature, okay? Right?
Yes.
So this will be one of the
Papa,
exercises we're
can I
going to do.
have a big one?
Okay, now, what is the difference between the heat and temperature? So heat, we know, basically is the energy, right? Temperature is a measure of how hot or cold a body is.
How about heat?
Heat is energy. Heat is a form of energy. Okay, so heat and temperature is related. That means the higher the amount of heat, the higher the temperature. The lower the amount of heat, the lower the temperature. Okay, I'll give you an example. For example, look at this. When you have two beakers or two containers, two cups, and then they have the same amount of water, right? And if the water in cup A is at 60 degrees Celsius, and the water in cup B is at 30 degrees Celsius, then which one have more heat? Definitely the one that is a higher temperature have more heat. Because a hotter water...
It's 60.
Yes, a 60 degrees Celsius is hotter than 30 degrees Celsius, right? It's more, right? The temperature is higher, right? That means there are more heat. Okay, so it takes more heat to raise the temperature of the same amount of water from room temperature 60 degrees. Therefore, beaker A has more heat. Okay, so heat is the amount of energy. But usually we use temperature to tell the amount of energy in, or the amount of heat energy in a body. How about another example? So you have another beaker that have some more water than a second beaker. So beaker C has more water than beaker D. And the water in both beakers are both at the same temperature, 80 degrees Celsius. So which beaker has more heat? Definitely, if they're both at the same temperature, a lot of people say that they have the same amount of heat, right? No. The amount of heat energy also depends not only on temperature, it also depends on the amount of matters or the amount of materials. Since beaker C has more water than beaker D, and the water are at the same temperature, we will definitely know that beaker C, the water in beaker C contains more heat energy than the water in beaker D. Just because that beaker C have more water than beaker D. So let me emphasize again, the amount of heat energy is not only dependent on the temperature, it is also dependent on the amount of matters, right? So how do things become hot or cold? Remember just now when we boil water, right? What do we do? The water gets hotter and hotter until it boils, right? Agree or not? That's why I tell you not to go near the water, right? So what makes the water getting hotter and hotter, or becomes hotter and hotter? We what?
Boil.
Yes, we boil it. We apply heat to it. We use the fire.
Can you
Yes.
do this?
Right, we use the water. We use the fire to heat out the water, right? So we actually boil the water, and we use heat. We put heat energy into water, and therefore the water becomes hotter and hotter. Correct or not? Now, when we cool the jelly right now, you see we are cooling the jelly, right? What are we doing when we're cooling? We let what? We let the heat energy from the water goes away, right? Slowly, the jelly will cool down. Agree or not? So how do things become hot or cold? It's a matter of letting the heat energy going into the body or getting the heat energy out of the body. When you apply heat into the body gains heat energy, right? The body becomes hotter and hotter and hotter. Understand? But if we remove the heat energy from the body, right? You take away the heat energy from the body. For example, you put the water into the fridge, right? The fridge is cold, so heat energy will goes out of the body. So the body, right, will get colder and colder, understand? So it's a matter of heat transfer in and out of the body. So for example, look at the first cartoon over here. It reads, the cold water gains heat from the surrounding, and therefore it reaches the same temperature as the room. So you take a piece of ice, or you take a cup of cold water from the fridge, you put on the table, right? Slowly the cold water will get heat from what? From the environment, from the surrounding air. So it gains heat. So the water becomes warmer and warmer, right? Same thing. If we put the cup into the fridge, the water into the fridge, it gets cooler and cooler because the water actually loses heat to the air in the refrigerator. Understand? So a body gets hotter or colder is actually depending on whether heat is going into the body or out of the body. So if heat is going into your body, it becomes hotter and hotter. If heat go out of the body becomes colder and colder. So this slide emphasizes the point I'm trying to get just now. Things become hotter when they gain heat. Gain means they absorb heat, they take in heat, gain. Things becomes colder when they lose heat. When the body or things loses heat, right, it becomes colder. Remember, heat always travels from a hotter place to a colder place until both places reach the same temperature. Then the heat transfer will stop. Remember, heat always travels from a hotter place to a colder place until both places reach the same temperature. Thank you, Hannah. Later. What are the effects of heat gain or heat loss on a matter like solid, liquid? When a solid, remember what's a solid, right? Like ice is a solid, right? Like this table is a solid. It's heated, it gains heat. What happens when it gains heat? When it reaches a certain temperature, it changes from a solid to a liquid. So it gains heat, it becomes a solid to a liquid.
Like ice melts
to become water, right? Liquid water, right?
But if you put strawberry inside there, it freeze into strawberry.
Yes, but later we talk about freezing, okay? When liquid is cooled, it loses heat and it changes from a liquid to a solid. Remember that?
Yes.
Remember that? Right, that is called freezing, right? Remember? Okay, so basically, freezing and melting are processes associated with heat gain and heat loss. So you need heat to be gained in order for melting to take place. You need heat to be lost in order for freezing to take place. Understand?
Yes.
Thank you, Abigail. So what happens when a liquid is heated? When a liquid is heated, it gains the heat again. But this time round, when it reaches a certain temperature, it changes from a liquid to a gas. What is this called? This is called what? You can call it boiling. You can call it what? Evaporation, depending on the temperature. And it's recorded, okay, you're yawn. When a gas is cooled, it loses heat and changes from a gas to a liquid. Okay, that's very rude, Okay, so far we actually talked about boiling, freezing, melting, freezing, okay, evaporation and boiling and condensation basically, right? There are more than just all these processes. So heat is always involved. So when remember with the three states of water, solid ice, liquid water, and gas, water, vapor, or steam. So basically when heat transfer is always apparent, is always existing between the three states. When solid ice gain heat, right, to a certain temperature, melting take place when solid ice is melted to give you liquid water. Okay, when the liquid water loses heat, right, when it's put into the refrigerator, right, when it reaches a certain temperature, the freezing process takes place and the water is freezed into ice. Same thing, when liquid water is heated, it gains heat, right, and evaporation takes place, but when it reaches a certain temperature, like the boiling point, 100 degrees Celsius, boiling will take place. Okay, boiling and evaporation will take place when liquid water gains heat. Right, in the reverse process, right, the water vapor gas or the steam will lose heat, right, undergo condensation to give you back liquid water. There are other process whereby ice or solid ice become gaseous water vapor, or the other way around. We'll learn it next time. These are called sublimation and deposition.
Japan.
This is some examples of everyday life involving heat transfer and the process of state change. Right, for example, the ice cream becomes a liquid, right? Your ice cream melts, right? When you're left in the room for a long time, or you're taking a long time to eat ice cream, the ice cream melts to give you a slimy liquid mixture. When you put your milk into a refrigerator or into the freezer, the milk will actually freeze to give you a solid, a milk solid, right? Okay, maybe next time we can actually try this. Okay, we learned about heat, right? Heat transfer, state changes that involve heat transfer, right? We know that matters gains and loses heat, but do you know that matters actually responds to heat when they actually gain or lose heat? So today, basically, we will actually explore expansions and contraction. When anything taking heat, it will actually expand. So matter expands when heated. Okay, so anything will actually do the opposite when being cooled. It actually contracts. What do you mean expand? Expand means become bigger. So if, for example, a piece of
Like I put
yes, food, anything
in my
yes,
hand and then it
yeah,
will become bigger.
it will become bigger because it takes in heat. Okay, once you take in heat, you become bigger. But when you say become bigger, doesn't mean it becomes like double the size, triple the size. No, it basically becomes so tiny bit bigger, but sometimes you cannot even see that it's actually become bigger. But all things expand when they are being heated. Okay, that means when things goes into the body, they will expand. Right? Conversely, or in the opposite direction.
Your body will grow bigger.
Yes, but when you're cooled, when a body is cooled, when matter is cooled, it will contract. Contract means what? Contract means it's getting smaller. Okay, when it gets smaller, doesn't mean it becomes very small or suddenly small and then you can notice it. Sometimes the contraction, the size or the volume of the contraction may not be that noticeable. Okay, so but remember, matter expands when heated, it contracts when cooled. Yes.
Daddy,
Is there a question about this?
Daddy.
Remember I said any solid, even a solid, when I say matters, right, includes solid, liquid and states. These are the three, liquids and gases. These are the three states of matter. So when they say matters expands when heated, it means more solid, liquid and gases. So a solid will expand when it gains heat and contracts when it loses heat. Again, let me emphasize, expands means bigger, being bigger. Contract means getting smaller. Okay? This is the typical ring and ball experiment. Basically, it shows you or demonstrates to you matter expands when heated.
What do you mean, Papa?
Okay, that's why when we need to do the experiment, then I go through this with you. It will be much better. Okay? So if a solid can expand when it gains heat and contract when it loses heat, a liquid will do likewise. So a liquid will expand when it gains heat and contract when it loses heat. Basically, we observe expansion and contraction of matters in our daily life. Okay, first, basically our temperature of our surrounding often changes, but not so much in Singapore. But if in temperate countries, where sometimes it gets cold and gets hot during the day and gets cold during the night. Yes, so the temperature of surrounding often changes. So the change in temperature often affects the objects around us because when the temperature changes, right, heat will be transferred from body to body depending on what is the So basically, when there's a change in the temperature, right, basically there will be a change in the direction of heat transfer between bodies. So remember, heat transfer always takes place from a hotter object to a colder object. So if the surrounding is cold, right, body will lose heat to the surrounding, right, because the heat will travel from the warmer body to the colder surrounding. Right, surrounding is the air around you. Okay, but if the temperature is very hot, like now in Singapore, right, the temperature is very hot, then the heat from the surrounding will actually goes into the body. Right, and your body becomes hotter and hotter. Remember? So definitely change in temperature affects object around us. And because objects expands and contracts when they actually take heat or actually loses heat, and therefore expansion and contraction, right, can also change the object around us. So when temperature is very high, object will expand and get out of shape. So when the temperature in the surrounding is very high, so the object will gain heat, right? Because heat travels from the surrounding to the object. So the object will gain heat, you expand.
And then it'll be bigger.
Yes. But when the temperature is low, then the body will lose heat.
Then it will get smaller.
Yes, object will contract. The word is contract and it gets smaller. Contract. And sometimes expansion and contraction will make the object becomes out of shape or even break the object.
Huh?
What
do you mean?
Later I tell you. To prevent such a problem from happening, right? We basically, some objects are designed to allow expansion and contraction, to allow the volume to increase and decrease, or the volume to become bigger or become smaller, without damaging the objects.
How? What do you mean?
What do you see on the picture here? You see wires, right? Cables, right?
Cable cars.
No, this is not cables for cable cars. These are cables for running electricity line. So that all the house.
Is it like so on the snowy day?
Yes, on the house, so that it brings electricity to all the households. So
very
some electricity,
high.
yes, it's very high. It's on a pole, and these are called cable poles, right? And there's this. Can you see all the wires are actually sagging?
Yes.
They are not like pulled straight. They are actually sagging. Can you see they're sagging? Right? Why are they sagging? Why are they hung loosely in this sense?
I don't know.
Because sometimes when the weather gets cold, right, they loses heat to the surrounding. And when you loses heat to the surrounding, what happens to the wire? It gets smaller, bigger.
Smaller.
Yes, when cooled, it gets smaller, right? When it gets smaller, if
then it'll be light and then
yeah, from the loose way, right, it can allow for things to be put slightly so that it can make taut. But if you put it very straight, very tight, right, if it becomes smaller, what happen? The wire will snap. Yes, it will break. You understand? So this is the design. That's why it's purposely hung loosely, sagging, so that when there's contraction, you won't actually break the wire. You won't just tear out the wire. You understand or not?
Yeah, okay. Afterward when it's fat.
If you tore the wire open, then the house will not have any electricity, right? There's no light, there's no electricity, there's no TV, etc., right? Correct or not?
And cannot have Zoom.
Yes, cannot have Zoom. Can you tell me what is this? Floor, right? It's actually, the floor is laid with what we call tiles, right? Can you see tiles? These are the pavement, right? Pavement
why
tiles.
they need holes?
Why they need gaps? We call them gaps. G-A-P-S. Why there are gaps? Because I said, when during a hot day, what happened to the tiles? It gains heat, right?
Yeah.
It gains heat, what happened? Does it become bigger or smaller?
Smaller.
No, when it gains heat, it becomes
bigger.
Bigger, it expands, right? When it expands, what happens? If everything is laid without the gap, they will actually push against each other and they will just break. Correct or not? Yeah. Then the tiles will come out, right? Correct or not? So there's gap.
Mean?
So the gap, there was space between each of the tiles.
What do you mean?
Okay, when they expand, right? If they are very laid tight to each other between each of the tiles, what happens when they expand? They'll push against each other, then they'll break, crack. Correct or not? But if there's space between them, I put some space between them, okay, a gap. Then when they expand, there are rooms for expansion, right? Then they won't hit against each other, agree or not? Yeah. Okay, so it won't actually crack. So this space or these gaps allow for expansion of the tiles. Understand? For lights also got gaps, right?
Do you take picture of it?
No, this is another picture. So this is the wooden floor is also they are actually made of planks like that. And basically we allow for space between them because we allow for expansion as well. So that when it gains heat on a hot day, when it expands or becomes bigger, it won't actually push against each other and crack. So it allows rooms for expansion. There are gaps in the room.
Only a little.
Yes.
Bit.
Expansion and contraction in our daily life. For example, you have two grass here, grass A and grass B. They are stuck together. So how do you separate the two grasses?
Can I press stop later?
Press stop. So we're going to use heat.
What are we doing? I remember this.
Yes. What we need to do is we actually place ice into the inner grass A, and then we actually submerge outside of the two grasses, which is grass B, in hot water. So grass B, because in contact the hot water expand, becomes bigger, glass A will contract, make it smaller because it's going to contact the cold ice. What's the question you want to ask?
Is it, you mean the bowl? He thought that it's with water, then you go up, float up.
No, it's nothing to do with floating or submerging. It's about expansion and contraction. Remember, all right, when you heat an object, you expand. When you actually cool down an object, you contract, become smaller. So what you need to do is, because you want to separate the two glasses, right, you can actually, right, make the inner glass smaller and outer glass bigger. So to make the outer glass bigger, which is the glass B, you put the glass B in hot water. And then in order to make the inner glass smaller, which is glass A smaller, you put ice cube inside glass A. So glass A gets smaller, glass B get bigger, and that's why they have a gap in between. You can
Can I do
actually
this?
separate them. You want to do this experiment? Okay.